Alrighty, guys. Today we're going to be talking about ellipses. I just recorded this entire thing and then recorded it without sound. So here we go for round two. Just a little FYI, your test is scheduled for conics on next Thursday, which is May 5th. Little Cinco de Mayo celebration, a little conics test. After today, we'll talk about hyperbolas, and then we'll talk about classifying conics, like how do you look at the equation and determine that it's a circle, an ellipse, or a parabola, or hyperbola, and then we'll have your test next Thursday. First thing you need to know is that there's two different types of ellipses. You can have a horizontal ellipse where it's stretched out more in the horizontal direction, or you can have a vertical ellipse where it's stretched out more in the vertical direction. I'm going to start out with the horizontal ellipse, and the first thing I'm going to give you is the base equation for a horizontal ellipse. It looks something like this: x minus h squared plus y minus k squared. Now you might be thinking, that looks like a circle. And initially it does. However, your denominators underneath here are going to be different. Or your coefficients that are out in front of x squared and y squared are going to be different. And it's also always going to be equal to 1 if it's in standard form. Some key parts of the ellipse that you need to be familiar with. Right smack dab in the middle here, you have your center. Just like with a circle, we label it HK. You'll notice that it has a different radius going left to right than it does going up and down. To find the radius going left to right, it is the value of a. You'll notice that in the denominator of x, you see a squared. So to find the radius that you go left to right, you just simply take the square root of a squared. To find the distance that you go up and down, your radius in the y's direction, it's b. To find it, you take the square root of b squared. You know that it's a horizontal ellipse versus a vertical ellipse because the x is going to have the larger denominator. So if x has the larger denominator, it is going to be a horizontal ellipse. Some other things that you need to add on to this diagram, at the end of the larger radius, the longer denominator, at the endpoints there, you're going to have a vertex on the left and a vertex on the right. The vertices are always located at the endpoints of the longer diameter. At the endpoints of the shorter diameter, you'll have something called a covertex. That is the main information for a horizontal ellipse. Give you a moment and make sure that you have everything down there. A vertical ellipse works similarly. I'm going to give you the base equation and then we'll pick apart the pieces. Starts out looking like a circle, x minus h squared plus y minus k squared. However, it differs from a circle in that it's always going to equal 1 if it's written in standard form. It's a vertical ellipse if your a squared is underneath y and your b squared is underneath x. You can tell the difference between a and b because a is larger. Right smack dab in the center of the ellipse, you'll have your center, which we label with h and k. To find the distance that you travel up or down, the radius in the y direction, it is the length of a. To find that value, you take the square root of y's denominator. To find the radius that you travel in the x direction, which we label b, you take the square root of x's denominator. At the endpoints of the longer diameter, so at the endpoints of this long vertical diameter, you're going to have a vertex up top and a vertex down below. At the endpoints of your shorter diameter, you have your covertices. So a covertex on the left and a covertex on the right. You know that it's going to be a vertical ellipse versus a horizontal one if y has the bigger diameter. Down beneath here, let's talk about some more key vocabulary words. Again, I spoke about this earlier, but the bigger denominator indicates the major axis. So the bigger denominator tells you which one has the longer diameter, the longer radius. The smaller denominator indicates the minor axis. So major is longer, minor is the shorter one. A is always the distance from this center to the vertex. A is the distance from the center to the vertex. I'm not sure why I put two blanks there. The length of that major axis is always A plus A, or 2A. B is the distance from the center to the covertex. The length of the entire minor axis, so you can think about it like the shorter diameter, is always B plus B, so 2B. Give you all a moment and make sure that you have all of those filled out, and then we'll flip it over to the back. Would be able to fill in the H, the K, the A, the B to write the standard form. On the back, the first thing I want to remind you of is how you determine if something's an ellipse versus a circle. It starts off looking very much like a circle, and that you have both x squared and y squared. So a parabola, the thing we learned about on the first day, is the easiest to recognize because you have only one variable squared. A circle and ellipse both have x and y squared. A circle and ellipse both have x squared and y squared being added. So x squared and y squared are added together. But an ellipse is different because x squared and y squared have different coefficients. Remember, a coefficient is just the number out in front of x squared or y squared. The rest of the notes are split into three parts. We are going to graph a couple ellipses, then we're going to write equations of ellipses when given different information, and at the bottom, we're going to determine how we know that those equations that aren't written in standard form are in fact ellipses. Let's zoom in on this first example. First thing, you know it's an ellipse because x and y are both squared. You know it's not a circle, however, because your coefficients in front of x squared and y squared are different. Take a look at these coefficients. You'll notice that in front of the x squared, we have a 1 over 36. So our denominator is 36. The denominator of y, since we don't see it, we can assume is 1. Now think to yourself, what's bigger, 36 or 1? Obviously 36 is larger. So that is telling us that this ellipse is going more in the left and right direction than it is going up and down, so we have a horizontal ellipse. We'll start out and find our center. Our center is HK. You'll look, and the x doesn't have anything inside the parentheses with it, so we can assume it's 0. The y has a -3 in the parentheses. You take that out as +3. So going up to 0, 3. Sorry, the sound messed up for a minute, but you should have a center at 0, 3. To find the value of a, you take the square root of the larger denominator. So we're going to take the square root of 36, which is 6. Since that larger denominator goes with x, we're going 6 in the left and right direction. So we'll go 1, 2, 3, 4, 5, 6 to the right, and 1, 2, 3, 4, 5, 6 to the left. Since that's the larger diameter, or the endpoints of the larger radius, we call those the vertices. So we have one at 6, 3, and we have another one at -6, 3. The shorter denominator we find by taking the square root of the shorter radius we find by taking the square root of the shorter denominator. So we take the square root of 1 and we get 1. So we're going to go up 1 and down 1. Those endpoints indicate our covertices. Once you have all 4 of those points, I guess 5 of them, you can make your ellipse. Your covertices should be located at 0, 2 and 0, 4. The length of the major axis is the distance from vertex to vertex. It's going to be 2 A's stuck together. So you can either do 2 times 6, or you can count from that left side to the right side. The length of the minor axis is 2B, so it's 2 times 1, or you can just count from covertex to covertex, and it would be a length of 2. So that is an example of how you would draw a horizontal ellipse. Go on down to the next example, and you'll notice that it looks a little bit different because this right side does not equal 1. If you're going to graph an ellipse, you want to make that right side equal 1. In order to do that, we are going to divide by that constant that's left over on the right side. We're going to divide everything by 1,225, and then we're going to simplify. In your calculators, you're going to simplify 49 over 1,225. 25 divided by 1,225, and this right side as well. You should end up with x plus 1 squared over 25 plus y plus 3 squared over 49 equals 1. From there, you can determine what kind of ellipse you have. You'll notice in this case that our larger denominator is in y's denominator. So this is going to be a vertical ellipse. Start out by finding the center. The center you find by putting h and k together. H is with the x, k is with the y. Don't forget to change the sign of both. So you should have -1, -3. To find the length of A, the longer radius, you take the square root of the larger denominator. Square root of 49 is 7. Since it's in the denominator of y, that means we go up and down 7. That is the longer diameter. Those endpoints are vertices. So we have a vertex at -1, 4 and -1, -10. To find the length of the shorter radius, you take the square root of the shorter denominator. So we get 5. That means you're counting right 5 and left 5, since it's in x's denominator. Connect all those outer points to make your lovely ellipse. The co-vertices are at the endpoint of the shorter diameter, so you should have 4, -3, and -6, -3. The length of the major axis is the distance from vertex to vertex. It should be 2a's multiplied together. 2 times 7 is 14. If that is hard for you to remember, then just remember that you can count from vertex to vertex. The length of the minor axis is the distance from covertex to covertex, or 2b's, so it's a value of 10. I was going to say see if you have questions there, but you can't really ask me a question in a video, but just take a moment and marinate in that for a second. Next thing we're going to check out is how we write an equation of ellipse if we're given different information. So in this guy, when I say write the equation of an ellipse, we're given the center is -8, 0. The center, smack dab, gives us h and k. Pretty easy to find those. The next thing they tell us is that the major axis, so the longer one, is vertical. So that means that our y should get the larger denominator, because it's going more in the vertical direction. And they also tell us that it's 22 units long. So you can envision something like this. They're telling us that the distance from the vertex to the vertex is 22 units long. That's helpful because we can take that and use it to find A. A is the distance from the center to the vertex. We can just take that 22 and split it in half to get 11. They tell us that the length of the minor axis is 16. Split it in half to get B is 8. B is 8. Once you know that, you can go ahead and write your equation of the ellipse. We have x minus h squared in our numerator, so we have x plus 8 squared. We'll talk about the denominator in a minute. Plus y minus k, y minus 0 squared would just be y squared, equals 1. When we're talking about our different denominators, since they told us that our major axis is vertical, we're going to take this 11 and put it in y's denominator. But we're not going to put it in as 11. We're going to take it and square it to get 121. In x's denominator, you use this 8. That's the radius in the left and right direction. When you put it back into the equation, you square it. So you should have 64. Take a moment and use those same skills to try out example 4. I'll give you a moment to try out this guy right here. We know our center is H and K. And this one, they tell us our major axis is horizontal. So they're telling us that X has the larger denominator. And that whole horizontal axis is 20 units long. Split it in half to find that A is 10. They tell us the minor axis is 6. Split it in half to find B is 3. So you should have had X plus 3 squared, Y minus 8 squared. 1 is on the right side. And then when you take these pieces and plug them back in, you don't plug it back in as 10 in the denominator of X. You plug it in as 10 squared, which is 100. And when you take this 3, you should plug it back in as 9. Last thing we're going to talk about is how we know that this equation here, this crazy long equation, is actually an ellipse. You know it's an ellipse because, first things first, you have x squared and y squared. So it's not a parabola. To determine that it's an ellipse rather than a hyperbola or a circle, you're going to want to move them to be on the same side. So we have 25y squared plus x squared. I know we have other things, blah, 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 blah. Sorry about that. But we mainly care about the x squared and the y squared. You'll notice that first, we have x squared and y squared. Second, they're added. And we know it's not a circle because check out these coefficients out in front. We have 25 and 1. Are they the same? No way. They're different. They have different coefficients. So that's what makes it an ellipse rather than a circle. The same deal goes for the one beneath it. We have 25x squared and 2y squared. They're added. They're both squared, and they have different coefficients. So all same 3 things. Now I'll give your homework a shot where you will do the same thing. You'll practice graphing. You'll practice writing equations, and then you'll practice determining whether it's an ellipse or not. Thanks for listening.